Yes, when it comes to the mechanism of action, these quinolones are bactericidal. As we are going to see, we say that they inhibit the activity of the DNA agarase and topoisomerase 4. We are going to use these diagrams as our demonstrations. This is the saturated DNA. It's the bacteria DNA. The DNA should be coiled such that it can fit into the nucleus. But in case of the DNA replication, this coiling, we should unwind this DNA in case of the DNA replication. But for example, if you try to pull these strands apart, this one the other side and this one the other side, for the replication to take place, you shall increase the coiling this side. When you pull like this, you reach a point when there is no more extension of the strands, as this one has supercoiled. This is what we call the positive supercoiling. So we need to unwind this DNA such that the replication can take place. What the DNA agarase does is to break these. I've labeled region 1, 2, and 3 for easy identification. Region 1, the DNA agarase will break these two strands. When it breaks these two strands, it will pull the two strands which are behind, pull them to the top, then joins these two strands back, meaning that we shall have this. The two strands which were behind, they are now on the top here, but here they are behind. Also, at this region, we shall have the same thing. Breaking these two, pull the other two up, then joins the two strands back. Even at position 3 here, we shall have the same. Breaks, pulls the two strands, joins the strands back. So we shall have them on top, which were behind. So this is what we call the negative supercoiling. Negative supercoiling allows the replication of the DNA. Now, for example, if these strands are tried to be pulled apart, remember this strand is now totally on top and this strand is totally behind. So when you try to pull them apart, they will separate easily, meaning that the replication will take place easily than here. When you separate these ones, you separate, but you reach a point when there's no more extension of the separated parts due to increased coiling of this region. So this is what the DNA agarase does to ease the replication, to reduce the breaking. Because if you pull and reach a point, there will be damage to the DNA. So to reduce the DNA damage. If there is DNA damage, there will be the production of the signals which leads to the nucleases. These nucleases will lead to the destruction of the damaged DNA, hence the cell will die. But here we are preventing the cell death because there is no damage to the DNA. So that's the role of the DNA agarase. So if it is inhibited, we can have the bactericidal effect due to the nucleases. Now, for topoisomerase 4, this topoisomerase 4 is responsible for the separation of the daughter DNA. It will untie them, the daughter DNA, from the mother DNA after replication. Hence, there is division after the replication. We can have cell division. But if it's also inhibited, meaning that the daughter DNA will remain with the mother DNA, so there is no cell division, and we shall have the bactericidal effect also. Why do quinolones have low effect on the human or on the eukaryotic cell? Because in the human cell, in human, there is the topoisomerase 2 instead of the topoisomerase 4. So this one, there is low affinity for this enzyme by these quinolones because it mainly targets the topoisomerase 4 and DNA gyrase. But in human, there is topoisomerase 2. Why do these quinolones also don't target or don't treat the syphilis? It's because the Treponema pallidum, which is responsible for the syphilis, lacks the DNA gyrase. That's why they're not used to treat syphilis. Now, when it comes to resistance is mainly by mutation in the genes which are responsible for the DNA gyrase and the topoisomerase 4. That's the gyre1, gyre A, and gyre B. The mutations in these genes, these two genes, leads to the resistance. The DNA gyrase has 4 subunits. The unit A has 2 and B has 2 of them. So, mutation in gene responsible for A subunits and also B subunits leads to the reduced affinity for DNA gyrase. Also, efflux. Increased efflux of these drugs leads to resistance. Also, the change in permeability of the membrane leads to the resistance, especially in gram negatives. If they have the change in the permeability of the purines, we may have poor entry of the drug into the microorganism. So, these are the main resistance mechanisms of these quinolones, mechanism of the bacteria against the quinolones.